Alright guys, so we're gonna start the class of air navigation. So before we get into the topic, obviously you guys would be familiar of what you can expect in air navigation. So coming to this subject, let us understand what all subtopics this subject has. Because eventually what you may think is air navigation is only about numerical, right? But eventually you should also have a theoretical knowledge of the subject apart from whatever the numericals you do. So before I brief you on this topic, what air navigation is, let us first have an idea of what the syllabus for the navigation would be, right? So I'll consider a basic idea of what to expect in air navigation. So listing out the topics of what we can expect here, let us say the topic we call air nav. All right. So first thing, obviously what everyone loves doing math is nothing but a general navigation. So in general navigation, let me write it in short. So general nav is all about doing numericals based upon trigonometry, you can say in basic language. You can also consider your basic kinematics where we calculate distance, speed, time. Further, if you add on, you also do something related to CX3, which is a scientific calculators where we'll also practice the CX3, how to use it, where you can find the virtual CX3 to practice before you go for the exam. Coming to this second part, all right, this is mostly a numerical section where you only do a lot of math. Along with math, you also do some theory topics, which when we start the topics, you will eventually understand that. Coming to the second part of navigation is instruments, instrument navigation. So what are these instrument navigation? So when we consider a flying, all right, we have some references to go from one point to another point. It could be in terms of your altitude, it could be in terms of your speed indication, it could be in terms of your direction indication, right? So there are several instruments that we as a pilot use for our navigation, all right? That is why it's called as instrument or instrument navigation. Third part we have is radio navigation. Now, what do you differently expect in a radio navigation? What we have here is we use a electromagnetic radiation or electromagnetic wave, just like you talk to your friends on a telephone, where we exchange our messages or voicemail or whatever you can say. So similarly, we as a pilot also use radio navigation for the purpose of communication, and also as we use the term navigation, it also helps us to find out our destination airfield, where we are particularly trying to go. We have a signals that indicates in the aircraft how we maintain our track to go to a point B. All right. So that is what we discuss in our radio navigation. Apart from these three, where most of the people wouldn't know what the subject is or what the entire syllabus is, where we have performance. Performance is all about aircraft during takeoff, during landing, during cruise, how we climb, how much of power is required, right? What is your takeoff speed should be, what is your landing speed should be. So all things we discuss in the performance of an aircraft. And it does have a good weightage in your exam when you consider. Apart from performance, the last thing that you can expect is flight planning. All right, like how you plan your aircraft, what are the things we do in a flight planning. Along with, we have weight and balance. All right, so here are the few topics, or you can say subtopics, which is combinedly into one subject called as air navigation. Right? So we'll be starting all of this and we'll discuss all these 5 or 6 topics that you can say in this chapter. All right, in this subject you mean say. So coming with the first topic, which I am pretty sure you all will be interesting to know, and you'll be always exciting to calculate. If you're a lover in math, if you love how to calculate a numerical, if you're good at math, you'll definitely love this general navigation. And if you hate a math, but still we'll try to make it interesting by using different examples, different methods of approaching to a numericals. All right. So guys, there's no one method of solving a navigation. There are plenty of ideas, plenty of thumb rules, whatever adapts and suits you, you can use that as a practice and that you can implement in your exams. All right. So if you see our notes, which is well simplified, made it accurately, which is suitable for your exams as well as for any airline that you want to prepare. All right. So whatever we got in our notes is much enough. You can easily follow this for your any interviews. Let's say if you're going for an airline or you're preparing for a DGS exam or whatsoever, this will be really handy for you. So coming to the topic of air navigation, like I said you, first part is nothing but about your general navigation. We have further topics in the general navigation, like you say basic nav, distance, departure, convergency, and likewise we have an index here which is eventually covered in next 30 days, you can say, or at least 20 to 25 days we'll do it. All right. Coming to the first and foremost topic, which is called as basic navigation. So if someone asks you, what do you mean by the word navigation? What do you mean exactly this word? What is the meaning of this particular word? If someone asks you, how do you define it? It's simple. Let's say you open your mobile phone, all right, and you want to go from A to point B. Let's say either you're booking a cab or yourself going on a ride, right? So what you do is you enter your destination point where you want to go. Just go to Google Map and put navigation, right? That's how you do it. So what does this gives us is, it's eventually giving us a shortest route, all right, a route that is less in traffic, which is safer to go. If there is any no entry or if there is a construction on the route, it still tells you and helps you to go from A to B, much saving your fuel and time, right? That's what the entire idea of navigation is. Here also it means the same stuff, nothing different. So when you consider the word navigation, it means that you are going from point A to point B. So A could be, let's say it's a departure and point B is your destination. For an example, let us understand A being Hyderabad, all right, and B being Delhi. You want to fly to Delhi, right? That's the destination. So what all you need, all right? I just have to take the passenger, or let's say you're only pilot who is flying the plane. You want to safely, efficiently, and possibly in the shortest possible time, you want to go from A to B. And that is what a navigation is. It is a method to fly from point A to point B within less time, with less fuel, and safely avoiding the weather. That's all you want, right? Let's say if there is a patch of weather, if there is a bad weather condition, if there is a thundering cloud, whatsoever, I wouldn't risk the passenger to go through it, right? So how do you go now? Obviously, I might slightly offset the route and go to point B. That is what the third thing we included in the navigation. Safely. You want to go from A to B, obviously not going through the cloud, but yes, you want to go safely from point A to point B, like avoiding weather, right? So there are a lot of things that we consider in navigation. Is it fuel efficient? Is it safe for the passenger? Is it safe for the aircraft? Is the aircraft flying within its parameter? Let's say if this aircraft can fly up to 30,000 feet, I won't be flying at 50,000 feet, right? So eventually you're considering all the parameters, and you as a pilot then deciding this is the best possible route for me to navigate from point A to point B. But before we coming to know a point A, let's say Hyderabad, all right? So how do you point out in Hyderabad? Let us say I got a chart. Let's say you got a chart for a reference, all right? You want to locate Hyderabad. So any point on the earth, all right? Any point on the earth is defined with the latitude and longitude. No matter whichever point you point on the surface of the earth, it is always given with the reference of latitude and longitude. That's the reason the first thing that you're learning in this chapter is the earth. All right. So let us understand some geography of the earth before we end up into getting into the topic. All right. So here, as you see, as you learn in your social studies, that there is a sun, which is nothing but a star for our solar system. And obviously there are several planets that are revolving around this sun, all right? One of which is Earth. So if we consider how far is the Earth from the sun, all right? Maybe not practically important for flying. Obviously there is nothing to do with this, but yes, for your understanding and for the exam purpose, you definitely have to remember these numbers, all right? So the distance between the sun and the Earth, all right, is considered to be 93.3 million statute miles. So we use the length, all right, we have different units like kilometer, miles, nautical miles, and something called as statute miles. So it says 93.3 million is the distance between Earth and the sun. And if we talk about the Earth's axis, all right, let me show you some other picture for your understanding. Let us say this is the Earth or a globe, whatever you called it. And you know, Earth as a planet is revolving, right? It is revolving from west to east. right? This side we have an east side, and this side you have a western side. So that is how the earth is revolving from west to east. But it is revolving on a particular point that we call as an axis. All right. So this is the line from the north towards the south, which is nothing but an axis of the earth. That is where your earth is spinning on its own axis in the direction of west to east. All right. Now, if you consider the same thing here, this is your axis. As let me draw it in another picture where you can have a basic idea of what the axis is. Let us consider this is the earth, and let us consider this is an axis, and this is how it is rotating. This side is the east, this side is the west. All right. So if you see this part, all right, the earth's axis is not exactly vertical. All right. Now let me give an idea what that means is, if I say this is the earth and this is your earth's axis, and it has been tilted, it is tilted by approximately 23.5 degrees. Okay, the earth's axis is inclined 23.5 degrees from the north, from the reference you can say, or from the normal you can say, right? And let us say here is the sun and here is the earth. All right, so this is the angle that you must remember. Obviously you must have learned in your schools in the subject of social studies, but yeah, here the number is very important for your exam purpose. So if I say it is inclined 23.5, how many degrees it is inclined from the orbital path? Let's say if it is orbiting in this direction, so it is 66.5 degrees from its elliptical path, or it can say orbital path, and from the normal it is inclined at 23.5 degree north. These numbers are must for your exam and you should remember it. All right, and it is pretty easy to understand by seeing the picture. You can say the earth's axis is inclined, it's not perfectly vertical, it is inclined 23.5 degree from the north, and if you see from the flatter side, that is nothing but from the orbital path, it is inclined 66.5. All right. Now if someone asks you what is the rotation of the earth's, let's say what is the direction of rotation of the earth, how does the earth spin? Does it spin from east to west, or it spins from west to east? It's quite easy. Like I've also explained you, the earth rotates on its axis from west to east, as simple as that. But yeah, some people even do a mistake on this. When you refer from the different perspective of North Pole and South Pole, it becomes slightly confusing. All right, let me tell you what does it mean. Yeah, here we have some numbers as we just discussed. It's about the length, the gap between the sun and the earth, which is 93.3 million statute miles. Next important thing that I told you is about inclination of the earth's axis, which is nothing but 23.5 degrees. From where? From its normal, and 66.5 from its orbital path. All right. So whatever we will highlight in our notes, all right, it's going to be handy when you do a revision. All you have to do is check out only the highlighted points. Anything that you mark, you can use your highlighters, you can use your pencil or pen, whatever is that, but you make sure you highlight your notes, because in your revision time, it saves a lot of time for you. All right. And this is very interesting. If I ask you a question which is very generic and you should know it, let us say there is day night, there is a changes in the year, and there is a changes in the season. Let's say there's summer, winter. Let's say after 12 hours there's a day, then further the night, and then you talk about year to year, which changes every 365 days, right? So what causes a day to night or a night to day? All right, you may say, let us say if the earth doesn't spin at all right, it's not turning at all, it's not spinning at all, then throughout one side of the globe will have an entire day, the other side will have an entire night. All right, they be in the dark throughout and you be in the day throughout. So what causes the day and night changes? Obviously it is the rotation. Because of the rotation of the earth, there is a changes in the day and night. If earth doesn't rotate, everything is going to stop, right? Similarly, what is the reason of changing in the year? Now you must be coming to the point. What I'm trying to ask here is, years changes not just because of rotation. The earth also has to revolve, has to complete one revolution across what? Across the sun. right? If it doesn't revolve, there's no change in the year. You'll be in the same year. So entire one revolution of the planet around that star is going to cause what? An year change. So here, revolution. So one revolution is going to cause a change in year. One rotation is going to cause change in day and night. So what does a change in the season is affected? Let's say if in India it's winter, do you think entire globe is going to have winter at the same time? Not really. Let's say if it's summer in Australia, in India won't be summer. So what I'm trying to say is, not every, like throughout the globe, the seasons are not the same. Alright? So that is what I'm trying to ask you a question here. The seasons are because of what? Not just because of rotation. It has nothing to do with revolution. It is to do with the inclination. This is the main reason where there is a change in the seasons. Let me explain you with an idea here. Understand the sun part. Let us say, I'll say this is the sun, all right? And let us say this part is the earth. All right? Let me make a circular picture so that you have a basic idea. So let us say this is the sun, the earth, all right? And it is inclined. All right? And let us divide one in the northern hemisphere and one in the southern hemisphere. This is after the inclination. So if you see the major part, all right, see the sun rays are mostly confined in this particular position. If you see, it is facing most of our northern hemisphere. It doesn't mean that there is no light in the southern hemisphere. There is a day, there's sunrise, there's sunset, but not enough heat that comes to the southern hemisphere. So what exactly you understand is, if I say, if this is the position of the earth at one point of time in an year, let us say the maximum heat goes into the northern hemisphere, so it becomes summer season in the north. It becomes summer season in the north, and south mein what do you have? You have the winters in the south. All right, you will have winter season in the south. The reason behind is the sun's declination. Major of your sun rays are facing towards the northern hemisphere. That's the reason they have summer. Likewise, let us say after 6 months, the earth is revolving, right? After the 6 months, the earth comes on this side of the sun. All right, let me draw you the same picture to understand this logic. And let us say the same earth with same inclination, 23.5 degrees. Now if you see, all right, the major of the sun inclination or declination, whatever you can consider, is facing towards which part of the earth? It is facing towards southern hemisphere. So they have summer, and in the northern hemisphere you got winter. So if someone asks you a question of what is the reason of causes in the changes in season, you can talk about summer and winter. So northern hemisphere and southern hemisphere will definitely have changes in the seasons. Let us say if it is summer in the Australia, we're going to have winters in India. As simple as that. So it's all about the sun's declination. All right, whichever the side the sun is facing more, that hemisphere is going to have the summer in that particular part of an year. All right, so this is what the basic idea and understanding you should have. But other than this, we also have another chapter called as solar system, where we're going to discuss more in detail about the suns and seasons. You can talk about how the solar radiation can affect the seasons. Okay, for this chapter, this is much enough for your understanding. But other than that, 3 things you need to remember. The day and night is because of rotation. The changes in the year is because of revolution. And the third thing just we discussed is because of changes in the season is because of what? Because of inclination. These are the 3 questions which are asked in the DGC exam, and you should know it. All right. Now, this is what we discussed so far. The earth is inclined. All right. The earth's inclination, this is what it says. The earth's inclination is the main cause for changes in the seasons. That's the reason the changes in the timings you talk about. Summers are longer, the day in summers are longer, nights are shorter, vice versa in the winter season, right? In the winters, the daytime becomes smaller and the night period goes longer, right? So again, that's the same thing, right? It is because of the inclination. Next thing, poles. Obviously, it's self-explanatory. But other than that, how do you define poles? Here we have one basic picture of the Earth. Talk about, this is the northern hemisphere, right? This is the point where all the meridians or a longitude, whatever you call first for this time, because we're going to discuss that by definitions. So this is the point on the top that is called your North Pole. Similarly, if you see exactly at the bottom, we have a South Pole, right? But what are poles? Poles are nothing but these are your ends, right? If I say this is an axis of the Earth, these are your end points of a particular axis, right? So north point, north end is called as North Pole. Southern end, right? The southern point is called as South Pole. As simple as what is explained in the notes, you can check it. They are defined as an extremities of an axis. The upper extremity is called as North Pole, which is nothing but on the top, right? And the lower extremity is called as South Pole. Now, very interestingly, what everyone must have seen since your childhood, कि Earth is spherical or it's perfect circular, or there is a debate, Earth being flat. People call it with different names and different shapes. But ideally, you have to understand what is the exact shape of the Earth. You can see here, even the Google Earth projects as a perfect spherical, right? But eventually it's not. The reason we're going to discuss it, but yes, you have to understand what is the shape of the Earth. All right. Now, let us say this is the perfect, what you can say, circle. Yeah. So this is the perfect circle if you consider. All right. Just imagine if this is a circle or a sphere made up of clay, and you spin this at a faster speed. What would happen to the clay? The clay will expand, right? Let's say you must have seen the people when they do pottery, right? They put a clay, try to make a pots out of it. Similarly, when this spins at a faster rate, there is an expansion in the mass that we call it as a centrifugal force, which causes it to distort a little, and the shape tries to go flatter on this side. And this is how the shape eventually evolved as kind of an oval, right? So it is not a perfectly spherical. The reason is simple, because Earth has a mass and it is rotating at a very high speed, it starts to pull across. There is nothing but a centrifugal force which tries to pull it outwards. That centrifugal force creates a shape that we call as an oval in plain language, in a slang word you can say, but this oval shape is called as oblate spheroid. Which is very important for your exam. Okay, they ask what is the shape of the Earth. If you end up selecting ellipse, spherical, or oval, try to use the correct word. That is nothing but oblate spheroid, which is also called as ellipsoid, or it is also called as geoid. It's been known with the three different terms which you have to know for your exam. Maybe not written in the notes, but you should write it down in your books. All right? Oblate spheroid, ellipsoid, and geoid. These are the three names this shape is known as, which is similar to an egg shape or an oval shape, you can say. Reason is simple. Because of the mass, the centrifugal force causes it to pull apart. Now, because of this shape, it appears flatter, isn't it? It appears flatter at the poles, and it appears bulgy. It bulges at the equator. This is very important. All right. What does that mean is, Earth appears, all right, flatter at poles. All right, because of the shape that is resultant out of the centrifugal force, it appears flatter at the poles. You can also say compressed at poles, isn't it? It looks like being compressed. That is the compressed at the poles. Third thing they can consider and ask you here in the exam is nothing but it bulges at equator. The reason that I have written these all is nothing but from your exam point of view, they sometimes ask you these stuffs. So what people do is they end up choosing a wrong in this, as in like they sometimes select they appear flatter at the equator, they write and compress at the equator, or they write it and bulges at the pole. But simple, as you see the picture, it is compressed at the poles, bulges at the equator, flattens at the poles, right? So please know this thing. Now, if we talk about a spherical shape, there is an equal radius. If I say this is a radius, right? The radius is similar in all the cases, and as well as diameter as well, right? Diameter is nothing but 2r. But if we talk about an oblate spheroid shape, all right, if we consider an oblate spheroid shape, this is spherical and this is an oblate spheroid, for an example. So if I talk about this diameter, all right, and this diameter, both are similar. There's no difference in the length if you measure. But if you consider for the oblate spheroid, the diameters won't be same. As in like what I mean to say is, if I consider one part of the axis, all right, let us say this is connecting from poles to poles, and another axis, if I connect them from equator to equator, obviously which axis do you think is going to be longer in length, which could measure more length, you can say? It is nothing but the equatorial axis. And if you talk about an axis that is connecting the poles, that is obviously shorter. So it ends up creating two axes. One is major axis. One is called as major axis. And one is called as a minor axis. Obviously, as the term suggests, the one which is smaller is called as a minor axis. The one which is longer is called as a major axis. So obviously you can say the equatorial axis is nothing but a major axis and the polar axis is nothing but a minor axis, right? So how much do you think these lengths are? Obviously you won't be using this for day-to-day life of flying, but yes, for the exam purpose you have to remember the length, all right, which is given in your books as well. Nothing different to worry about this. If you check out your notes, it's given, all right. All the points that we discussed, please remember oblate spheroid is also called as ellipsoid and geoid that we just discussed, right? So three terms for this word is important. Second thing I said you is slightly flattened, all right, and that is flattened at the poles, which is also going to create a compression at the poles, right? And that is going to create two different axes. Okay, this is what I was saying about polar, equatorial. Polar is also called as minor axis, and this is called as major axis. All right, you should know the values. So one is major, 6888 nautical miles. We'll know what is nautical miles soon. And one is 6865 nautical miles. Very important, all right? Because there's something called as compression ratio, which is the next topic. All right, we're going to discuss about the compression ratio. So let us see how this is considered for numerical questions. So what is a compression ratio? The compression ratio is nothing but it is a ratio of two things. All right, here we have one numerator, another is a denominator. All right, so you got a denominator and numerator values. So if you see, it's a major minus minor axis divided by a major axis. Simple math, nothing different. So if I consider the values, okay, what we just done, 6888 minus 6865 divided by 6888 nautical miles. When you do this math, what you get here is, obviously 88 minus 65 is how much? 23. 23 upon 6888. It gives you a value which is nearly to this equation, to this ratio you can say. 1 by 297, 1 upon 297. For a rounded up value you can say 1 by 300. Is this value correct? Is that value correct? It could be a misprint, but yes, is that value correct? 1 upon 300. Is it 0.03